Okay, what's up? I thought I'd go through some topics. So this is further applications of area and volume. I'm just going through the questions from the textbook, just the last sort of summary questions. Okay, so let's see. So find the area of an annulus. That means it's like a ring, like an outer circle, inner circle. The inner diameter is 7 and the outer diameter is 8. So we're going to do, in fact, there's a formula. So pi, you can do pi r squared is the area of a circle and subtract them. We can actually do it in brackets. I'll just write it. It's r squared minus little r squared. Okay, it is in your formula sheet. Actually, let me just show you. This won't take long. Give me a second. Here it is. Yep, found it. Okay, so yep, circle, pi r squared, and annulus. That's the one we're using. Let me see, where was I up to? Okay, so in this case, the area will be pi. The big radius is 4, okay, not 8, just half of that, and half of 7 is 3.5 squared. Okay, I'll use my little program here, Python. Okay, I've got to use maths, so math.pi times 16. Okay, I know some of this off by heart, so 11.78 is what I got. So this one, okay, and the unit is going to be squared and it was in meters. Okay, so that's it. So B is the answer. Next one, the sector. Okay, so it's part of a circle, a certain fraction of a circle. So the area of a circle is pi r squared. So in this case the radius is just 3, but then we need to times it by, it's not a full circle, it's a fraction. And think of a full revolution, which is 360 degrees, so that's what we need to do. So math, I'm trying to just go fast. You can rewatch it, rewind if you need to. Also, you can pause it before each question. Okay, 6.44 centimeters squared, just 2 decimals. Okay, so 6.4 will be the right answer. Okay, composite shape has a square of side length 6 and a circle of radius 2 removed from the center. Okay, so that one's easy. I'm going to get rid of these. You can copy them if you want. Oh, of course it can't backspace, so I still don't understand that. So we're going to do the area of a square is just 6 times 6, or 6 squared. That's why it's called square, because it's the area you get in the square. The circle has radius, so okay, so pi r squared. So just now, yeah, it's all in millimeters, so that's all good. So 36 take away 4 times math of pi, so 23.43 millimeters squared, square millimeters, which is small. So 23. Okay, next one, Simpsons Rule. Okay, let me just, I'll keep encouraging you to use the formula sheet. So Simpsons Rule, there's 2, but they're really the same. We want to use this one. Okay, yeah, so it's just the pattern, FML 141, okay? So the area is going to be approximately, this is an approximation, start with the h, which is 10 over 3. In fact, I'm going to encourage, I'll get rid of that. Every time you do Simpsons Rule, first thing, write down what h is. 10. The meters doesn't matter too much, but that's fine, 10. Okay, so we've got 1 of the first thing, doesn't matter if we go down or up, but so just 8. What is it doing? 8 plus 4 lots of 12. 4 times 12, or 4 brackets for the 12, and then just the 4. 8, 4 of that, and then that. Okay, so whatever that is. Can I do it in my head? 48, 52, 60. Yeah, I think it's 200. Is 200 the answer? Oh, it's a formula. I didn't even notice that. I'm pretty sure, so that one. So C is the answer. Okay. Alright, let's keep going. And that'll be in meters squared. Okay. Rectangular prism is easy. Surface area though. If it was volume, you would just do the length times the breadth times the height. You just times them all. 3 of them because it's 3-dimensional. But because it's surface area, let's see, surface area. The easiest way I can think of doing it, you're going to get pairs. You're going to have the top and the bottom, front and the back, the right and the left. They'll match. So you've got to do 2.5 times 3. That's one of the sides, and we're going to double it. That's why I put a 2 out the front. We've also got the 2.5 by 2.8. You're sort of timesing every combination. That'll be another one of the sides, but there's 2 of them. And there's also the 3 by 2.8, and there's 2 of that side as well. So that's a nice way to do it. You can't do it much faster than that. Alright, so 2 times 2.5 by 2.8, 3 by 2.8, okay, 45.8. So this one. Okay, and again, yeah, ask me for help in class if you're not sure. Alright, the volume of a rectangular prism. Okay, it's the same question, just the volume, you just times them. So volume equals 2.5 times 3 times 2.8. I'll just use the calculator just to be reliable. So 21 meters cubed. Alright, 21 meters cubed, so D is the answer. Okay, this one. This looks tricky, composite solid. It's hard to tell, but I'm pretty sure it's a cone and a cylinder. Okay, so I'll get rid of this. You can copy it if you want it. Come on. Maybe I should set it up so I keep everything and then just keep moving down. Anyway, so for a cylinder, it's going to be pi r squared h. Okay, let's try to find it for a cylinder, that's surface area. So, okay, just the area times the height, but the area is pi r squared times the height. And for a cone, it's the same, third, but then pi r squared h. Okay, anyway, we'll get there. So the radius of the cylinder is 2. So pi times 2 squared times the height is just 1 plus, that's the cylinder. So the cone, we have to do a third times pi. So the radius squared is still 2, so 2 squared. 2 squared. And the height of that one is 2. Okay? Now, I can try to take some shortcuts. You can just put that in the calculator. See how they both have a pi? They both have 2 squared, which is just 4. So you can take that out. 1 plus 2/3. I'll just do it on the calculator. So times 4. Don't need to do times 1. A third times pi times 4 times 2. So I got 20.94. You get the units. So meters cubed. Okay, so C. Alright, number 8. A square has... Okay, so side length is 4.2. The percentage error, so it could be 4.25. Just imagine a 5 after the 2. Like it could be a little bit more than that, or a little bit below. Okay, so the error is 0.05 centimeters. Okay, so the percentage error, I'll write it out. percentage error is 0.05 out of 4.2, and then times that by 100. That's how you find things as percentage. You just divide it as a fraction, times that by 100. 0.05 over 4.2 times 100. So 1.19%. Yeah, that'll do. So which 1.2%. Okay. Yep, that's it. Oh, for the area. Hang on, I think they're trying to trick me. Oh, that's, I don't even know. Okay, sorry, that's the percentage error for the length of the square. I have to think. For area, I don't know what they actually want you to do. Because that's weird. If you square it, it's more complicated. Like if you did 4.25 squared, let's just see what that equals. I think that's more complicated than what you're meant to do. You get 18, whereas if you just did 4.2 squared, so maybe you're meant to look at that difference and compare it to the, well, let's just try that. 18.0625. Yeah, I think that's much more complicated than what you're meant to do. But like, let's say, so I'm comparing how big it could be to how big it should be. Like, that's how far off it could be. 0.4225. I need to compare that to the real value of the area, and then times by 100. So I got 2.39, so about 2.4. So I think that's the answer, but I don't consider that obvious at all. So don't worry about that. I guess maybe you meant to just double it if it's area. I'm not sure of that rule. Okay. Let's keep going. Find the area. I might not do all of these just because there's so many that's so similar. So for this one, the area, we're just gonna do, I'll just quickly write, maybe I won't do the calculations, just the formula. So the area is just pi r squared, so pi times 1.4 squared, and that'll be in millimeters, square millimeters. The next one, you just do, so pi, same formula as before. We already know the radii, so wait, I'll just write radii. That's the plural of radius. 4 squared minus 3 squared. Okay, that's it. That's for B. And for the last one, this one is a little bit trickier. I'm still going to do the same thing, pi r squared. But it's not a full circle, it's most of a circle. But we need to figure out what's 360 take away 83. So you can write that somewhere separate. So I think it's 277 degrees. Okay, so it's going to be 277 out of 360. It's most of a circle, but not quite. In fact, it's about 3/4 of a circle. That's what you do for that one. Okay, so that's A, B, C, whatever they equal. Okay, question 2. Semicircle. Okay, so it's a semicircle. Diameter of 40. I don't get the picture. How does that help? So we know the diameter and the depth. Okay, so cross-sectional area. Let's do this one. I'll get rid of that as well. So the area of a circle, again, it keeps coming up, pi r squared. But the radius is just 20, because the diameter is 40. And then the only other thing is we need to divide it by 2, because it's a semicircle. Or times it by a half, same thing. So that's the answer to the first one. That's the cross-sectional area. Okay, for the volume is actually really easy. It's just AH, the area times the height. So we're just going to do whatever that number was from this part, that number, times 15. Everything's in centimeters. 15 is the height, the depth. So that'll be in cubic centimeters. Alright, how about, let's just quickly figure these out. Times 400. Okay, so this is the first one. 628.3 will do. Square centimeters. Okay, and then times it by 15. 9424. 0.8 will do. Centimeters cubed. Okay, so how many liters? A liter is just 1,000 cubic centimeters. Alright, let's see if that's in your formula sheet. Okay, so 1 meter cubed is 1,000 liters. Is that all it tells you? Okay, a good one to know is that 1 liter is 1,000 cubic centimeters. And so relating to that, 1 milliliter is 1 centimeter cubed. Okay, those are good to know as well. And this is also a kiloliter. 1,000 liters is just a kiloliter. So a cubic meter is a kiloliter. Alright, so how many liters? I can actually tell about 9.4. Okay, how many thousands are there? There's 9.4 thousand. So 9.4 liters. Alright, let's keep going. So this is a composite shape. The area of the rectangle is just 8 times 6, 48. The area of the triangle, you just got to do base times height. This is actually the height, half base times height. So this is 3, this is 8. So let's do this one. So let's just do the shaded area straight away. So we're going to do 6 times 8 is the total area. Take away the triangle, which is a half, times 3 times this vertical height, which is 8. Okay, and you can take a shortcut here. So half of 8 is just 4, times 3 is 12, 6 times 8 is 48. So 48 minus 12, or use a calculator. So 36 centimeters squared is their shaded area. Okay, hopefully you can see that. Just making sure. I can't tell where the... Man, what is going on? Hang on. Where the cutoff is. Alright. No. Okay, let's do this one. Okay, so it's a weird shaped field, but notice this is flat and this is flat. So we're going to do the right hand side and the left hand side and then add them. So it's just using Simpsons Rule. They're still approximations. So let's figure out h first. H is the width of each section. So it's 24 meters. So do 24 over 3 times, okay, so the first length, we're just looking at the right, is 6 plus, so FML, first, middle, last. The middle is 12, but we times that one by 4. And the last is 6, okay? That's on the right side. You might want to do something like that. Area on the right, and then area on the left is going to be the same sort of thing. 24 over 3, because it's still the same widths. The first is 5, and then 4 lots of 9. Okay, 4 lots of 9 and 11. Okay, so whatever those two things are, you add them and you get the total. So area total. For example, you can set it out how you want. Maybe just an R and an L and a T. It's up to you. And that'll be in square meters. Alright. Find the surface area of a square prism. What, is this a trick? Slant height of 6. What is it talking about? Square. Okay, so let me get rid of this. So it's basically makes no sense. You've got a square going up into a prism. So the area of the square is easy, 7 times 7, and the same on the top. For the slant height, that's weird. I don't think that's obvious. Those side walls would be like parallelograms. I'm going to leave that one. I don't actually think there's enough information. I don't know what they're talking about. Actually, you know what? Let's just say... Oh, wait. Oh, sorry. It's just a square prism. Why am I getting... Yeah, I don't... What do they mean by slant height? Slant height. Square prism. Do they mean 7 across the bottom, and then we don't know the height, but the diagonal is 6? How's that even possible? The base is 7. How can the slant... I'm just going to say the height is 6. I don't know what they mean by slant height. Let's ignore the word slant. Okay, in that case, the volume is easy. 7 times 7 for the bottom times 6. 7 times 7 times 6. But surface area is also easy. So we just do, remember, put a 2 out the front. We have 2 lots of the 7 squared. One side's going to be 7 times 6, but the other's also going to be 7 times 6. In fact, actually, maybe better way. We've got 2 lots of the 7 squared, the top and the bottom, and then the other 4 sides are all the same. They're all 6 by 7. Okay, you can draw a picture if that helps. Let's skip that one, but slant, I don't know what they mean by that. That answer will be centimeters squared. Okay, let's move on. I want to check how much time this has been. 22 minutes. Alright, let's keep going. Closed cylinder. Okay, so the radius is 6, the length is 14. So the area of this closed cylinder means it includes both ends. Okay, so the area of this end is easy. It's the same as always. Pi r squared. So pi times 6 squared, whatever that is. For the surface area of the cylinder, we can just use this one for a closed cylinder. Notice the 2 pi r squared is just the caps, the top and the bottom. A circle at the top and a circle at the bottom. That's why it's 2. And this fancy part is the curved sort of section that goes around the middle, this bit. So we're going to do area is 2 pi, so, whoops, sorry, 2 times pi times 6 squared, 2 of that, the top and the bottom, plus 2 times pi times the radius, which is 6. That actually tells you this distance around, and then you're going to times that by how long it is, times the height or the length, 14. Whoops, that'll tell you the total surface area. Okay. A label covers the curved surface of a cylinder. Okay, this one's easy. I'm pretty sure that label is just this section. Okay, not the circles. So this time we're basically going to do the same as that part. So the area of the label is 2 times pi times the radius is 8 and the height is 12. That's it. That's all you need to do. Okay, the next one. Okay, it's closed, but there's a hemisphere surface area. Okay, I can visualize what it is. We basically got this, but with a sphere on the end. A bit like the shape of a bullet or something. Okay, so first we can do the base, which is just a circle. So pi r squared. The radius is 4, just half of that. Okay, plus. So it actually starts off the same as this, but instead of 2, we only have one circle. The other circle we have to do a sphere. So 2 times pi times, so the radius was 4 again, and the length is actually 4 as well. That's the middle section. So this is the circle, this is the middle section, and then we need to do the sphere on the end. So the surface area of the sphere is 4 pi r squared. Let's just look at it. There we go. 4 pi r squared. We only need half of that because it's half of a sphere. So 2 pi r squared. So we're going to do 2 times pi times the radius squared. So this all looks like just a bunch of crazy stuff. You can do it in parts if you want. Notice this and this are actually similar. It's sort of a coincidence. Pi comes up a lot with any spheres and circles, that sort of thing. But anyway, that will be the answer to question 8. Okay. Alright, number 9. Okay, yeah, we may as well practice this. I'm going to get rid of that. It worked for once. So the surface area of this hemisphere, again, 4 pi r squared is a full sphere. So we just need half of that, 2 pi r squared. Pi, radius is 0.8, square it. That's the bottom part, and then we've also got this circle. And that circle is just pi r squared. Okay, that's it. So whatever that equals, and that'll be in meters squared. Okay, surface area of a sphere. This one we have to work backwards. So for a sphere, it's 4 pi r squared. Okay, and in this case they told us that it's 153.9 square centimeters. So I need to make r the subject. So ignore this part. In fact, we can just get rid of that. How do I get r by itself? So I need to get rid of 4 pi. So I can divide by that. 153.9 over, and I'll put pi here as well. So I divide by 4 pi, or 4 times pi. And then to get rid of the squared, I have to do the opposite of squaring, which is square rooting. 2.9. Okay, and then don't forget the pi. Okay, so that's the radius. So that one's a bit tricky, you have to work backwards. Whatever that number is, that'll be the answer in centimeters. Alright. Yeah, I'm going to try and keep going so I don't lose all of this. So this is a composite shape. This is an outer rectangular prism and an inner one. So we're finding the volume. I actually have another shortcut, but this way is actually pretty quick. Okay, so the outer volume is going to be 8 times 5 times 6. Okay, which is like 240 cubic meters. Okay, the inner is gonna be just 3 by 4 by 8 again. The order doesn't matter too much, so that's 12 by 8 is 96 cubic meters. So the volume of what we're looking for is just, you subtract them. So 240 minus 96, which is 144 meters cubed. Okay? Okay, last one. So she measured it as that. So the absolute error is just how much off. She was off by, in this case, 0.1 centimeters. So 1 millimeter. That's how far off she was. The relative error, percentage error. Okay, I know what percentage error. I don't know what they mean by relative error, to be honest. I don't know what they're talking about. But percentage error, I would do 0.1 over 5.4, compare it, and then times that by 100. Okay, so 5.4 times 100, so 1.85%, 2 decimals. That's the percentage error. Okay, and look, I don't know about these, the absolute error for the volume. Yeah, I don't know. Alright, okay, look, I'll just try. Okay, the actual volume of the cube is 5.4 cubed. So let's figure out what that is, which is 157.5 cubic centimeters. That's what its actual volume is, apparently. But she was off by a bit, so 5.5 cubed. What she would calculate it as 166.4. Let's do the same number of decimals. So then we can compare them. I'll just do it like this. So subtract them, I get 8. So let's just say error is 8.91. Yep, that'll do. Centimeters. So that's how far off. Like, even though she's only 0.1 centimeters off, when you calculate the volume, this is how far off it ends up being. Now that as a percentage, 8.91 over, compare it to the real value, 157.5, and then times that by 100, and see what that is. 0.91 over 57. This should be close enough. So I'll just say 5.7% error. So notice, once you start making assumptions, even with a small error, you start calculating other things, the error gets bigger. So when you cube it to get volume, it's a bigger error. I'll look up what relative error means compared to absolute. I'm really not sure what they mean. But anyway, hope that helps. I'll leave it there. Bye.